All right, scholars, we have made it over our halfway hump during our statistical journey, and we have arrived at what many would consider a very complex statistical topic known as the margin of error. So, we're going to spend some time over the next couple of lessons fleshing out this idea. The margin of error, calculate the margin of error for a population proportion estimate. So I can use data from a random sample to determine an estimate for a population proportion. I'll know I've got it when I understand that different samples from the same population can still have different statistics. So the reason why we need to use something like the margin of error is oftentimes we don't have the ability to gather large, like extremely large amounts of quantitative data because it takes a long time. It's extremely tedious. Those are probably the two, and you might not have the access to it. So instead, we try to select a sample population and take those results and try and generalize them for the entire population. Um, so that being said, um, since we are dealing with proportions, I'd like for you to mentally evaluate the proportion of chips that are blue based on these descriptions here. 17 are blue out of 50. What does that proportion look like? You can input it as both a fraction or a decimal. Um, so share those ideas with the class before we head to our first activity. So our biologist is breeding fruit flies to include a specific genetic mutation that will be useful in understanding memory in humans. Um, Analyzing this DNA winds up killing the fly, so the scientist only wants to test a sample rather than all of them. So he selects 40 flies, or she selects 40 flies to sequence at random and finds that 9 of them have the genetic mutation. What would that proportion be? Think very light here. There's only 2 numerical values that you have available to you. How could you put them together using mathematics to calculate the proportion? So the scientist is worried that only having one sample may not be reliable for estimating the proportion of flies with the mutation, but doesn't want to sacrifice more flies to obtain a larger sample. So 4 different ideas have been proposed. Make sure that you read through those ideas and answer the questions accordingly. When trying to calculate the margin of error, okay, the margin of error is the value that we add or subtract to the sample mean that would still provide us with a 95% confidence interval, assuming that the data that you have is normally distributed. So, furthermore, what that implies is not only do we need to know what is the sample mean of this data, but what does the sample standard deviation also look like? Because that will inform us as to the range of values that encompass both 2 standard deviations above and 2 standard deviations below the mean. Okay? And that's what we would define to be the margin of error. We're going to pause at that point in time, but I do want to bring you to the lesson 10 summary that does a very nice job streamlining and simplifying this idea for a margin of error. Right, I'm not going to read it here because this is a video, and what's the sense in watching a video that I'm reading? But I strongly encourage you to read through this, notate it. If we need to flesh out any of these paragraphs, we certainly can do that during our time together. But please come prepared with questions because this is not a topic that you should take lightly.